Hello everyone and welcome to day 2 of definite integrals. Last class we looked at Riemann sum and how to approximate the area looking at rectangles. So looking at this problem using your knowledge from last class to evaluate 3 dx. Well, if we look at an xy axis, we say 3 is there, 2 to 5. So remember that this is your bounds, 2 to 5. Of the line y equals 3. And then we're looking from this area. So this is a shaded area. And in this case, we're using our knowledge. So it's just, what is the area of the shape? Well, it's 3 by 3. So the area of a square equals 3 times 3, which is 9 units squared. So pretty easy right there. 9 units squared, you have an area of a rectangle, or a square in this case. It could be a rectangle though. So now, let's look at a little more difficult problem of the line y equals x minus 1 from 0 to 3. So, you know we have a slope of 1, y-intercept of negative 1. So we've got that. And we're looking from 0. We know that's at 1, 2, 3. And right there better be 2, if we did it correctly. And so, we're looking at the area between two different areas here. We got this area, which is we're going to call it A1, and then this area of a triangle, which is A2. And so we know the area of a triangle, 1/2 base times height. And so if we look at this, this is actually -1 being the height. So the area A1 is going to equal 1/2 the base 1 times the height, actually -1 here. So that's going to be -1/2. The area of 2, the second area, 1/2 base 2 times height 2. You get 4 over 2, which is 2. And so what is the integral from 0 to 3 of x minus 1? Well, we're going to do -1/2 plus 2. We're going to get 3/2 there, or 1.5, but we all know I like fractions a lot better. So the key here is area of something below the x-axis, which has a height, in this case a rectangle or a triangle has a height of -1, is negative area, positive area here. So that's the two differences there. So we have to actually add this one and that one together to give us 1.5. A couple rules here. The area of A to B, you go opposite. B to A is just the negative of that. So if I had gone from -3 to 1, it would have been -2 instead of +2, just going backwards there. And in this last part says the integral from A to A. Now, if we think about that, how much did we move on the x-axis? If it's A to A, we didn't move at all, so the area is 0. So that's the key part there. You can look at the properties of integrals. There's nothing I really need to go over there. So we have this picture of a line that we can break into 3 different segments. Area above, below, and above again. The area of this is 2, 4, and 1. Now the key here is that this is really -4 though. So from A to B, 2. B to C, -4, C to D, 1. In the area from A to D, all of this combined, we would just add up, which is just -1. Hopefully that makes sense, and you don't need much more explanation. If you do, come see me. Another property, and this is a little more, you got to actually think about it, A to C. So if we look back up here, A to C plus C to B. So make sure you look at here. C to B, we're going backwards. So A to C plus C to B is just A to B. So if we think about it, since this is backwards C to B, we can use our property, the integral of A to C minus the integral of B to C equals A to B, which should make sense to you. If you're just subtracting B to C, you're left with A to B. So an example here, 2 to 9. So I make a number line. 2 to 9, 5 to 9. So we know 2 to 9, all of that. That's what we're trying to find. So 5 to 9 is 8, and 5 to 2 is 3. We know that the integral from 2 to 5 then of that equals negative 3. Again, we just negate it. So we know integral from 2 to 5 is negative 3, and therefore what is the entire spot? That equals 5. Okay. Now we're going to talk about the fundamental theorem of calculus more in class and how it relates, but just a quick, very quick overview. The integral from a to b of f of x with respect to x is the antiderivative, so the integral of f of b minus f of a. So all we're going to do is find the integral and then evaluate b and subtract it from at a, evaluate it at a. And that's all that is. Again, we will talk more about it at class. Do not think that's all there is to it, though. So on to the third page. What we are going to do here is just very quick computation. So in this case, let's take the integral. Using the fundamental theorem of calculus, part 1, we are going to take the integral, so x squared over 2 minus x, and evaluate it from 0 to 3. So we take the integral, and now we're going to plug in 3 and plug in 0, subtract them, and there it is. So you're going to get 3 squared over 2 minus 3 minus 0 over 2 minus 0. So we're going to get 9 over 2 minus 3 minus 0, and you are going to put that over 2 and get 3 halves. And done. So again, I'm doing these quickly. Take the integral. The correct notation is, this is showing how you evaluate it from 0 to 3. These are your limits. You plug in 3 into the entire integral, subtract it from the lower bound, plug in 0, and then evaluate it out. I'll do the top row, and then I'll let you guys do the bottom 2 and show the answers at the end. So again, we're going to go evaluate the integral. This is really x to the 1/2, so add 1. X to the 3 halves, divide by 3 halves. Notice that when we divide, we multiply by its reciprocal. Always want to make sure we're doing what our bounds are from. So we're going to get 2/3. I'm going to keep that out in front. That is a constant of 9 to the 3 halves minus 1 to the 3 halves. 9 to the 3 halves, let's talk about that. That's really saying the square root of 9 cubed. So we're going to say it's 27 minus 1. So it's really 2/3 times 26. And so that is 52 over 3. That should be the answer to that one. Okay. And the last one that we'll do together. This, again, we just took the quiz on this, or the test on that. X squared, x to the 1/2, we know is x to the 5 halves. We add them together. So we're going to get the integral from 4 to 9 of x to the 5 halves dx. We know that, add 1 to that, so we're going to go x to the 7 halves over 7 halves from 4 to 9, which is 2/7 multiplied by 9 to the 7 halves minus 4 to the 7 halves. And again, don't get too confused with this. This is saying the square root right here. When you have something divided by 2, it's saying the square root. So that's really saying 3 to the 7th minus 2 to the 7th. And that is going to give us, if you use a calculator, 2/7 times 2059, which is also equal to 4,118 over 7. Okay, so I want you guys to do now is try the next 6, and I'll come back with the answers and with anything that you should have noticed. So the next 3, this one should have been straightforward, 18. This one, remember that the integral of cosine does not change signs, and so therefore it's sine x, 0 to pi over 2. You know that sine of 90 degrees is 1. It's at the top of the unit circle. Sine is 0, 0, so we get 1. In this one, you need to recognize that 1 over cosine squared phi is secant squared phi. The integral of secant squared we know is tangent. And then tan of pi over 3, remember it's sine over cosine. Sine of 60, square root of 3 over 2 over cosine of 60, 1/2. 2's cancel out, you get square root of 3. Tangent of 0 is 0. So that is the next 3. And here are the final 3 answers. I guess the only couple things here is knowing that that turns into a 3. Anything to the 0 power is 1. The absolute value is why it's important that you remember its absolute value. And this last one is a complete and utter pain. I understand that. I hope that you know you didn't have to do it all out, as long as you got the idea of it. I even made a mistake while doing it. So there it is. Of course, we couldn't end without a joke. What do you call an alligator in a vest? So what do you call an alligator in a vest? An investigator. Ha ha ha. An investigator.